that was an awesome talk. I appreciate that. What I'm going to be talking about is very much in the same vein, just sharing basically our approach to doing very similar things. You know, basically, I'll get into it obviously with the slide where once it pops up, but you know, the whole idea is how do you run a actual network, you know, at scale, and how do you actually do intent-based networking on that? Yeah, so Chris Cummings, network automation software engineer, Energy Sciences Network. It's part of Lawrence Berkeley National Lab, which is also part of the U.S. Department of Energy. So lots of government intermingling, things like that. Real quick, like basically we run an ISP style network. It looks like an ISP network. It's got fiber, it's got routers, it's got all that stuff. But it's a little bit different than perhaps a traditional ISP like a lot of y'all folks work on. So, you know, you typically have like, you know, Google, like your hyperscalers, you got your regular ISPs like AT&T or, you know, Lumen or whatever they're calling themselves these days, right? But then you have the whole research and education group, right? This is like universities, regional optical networks. Europe has a ton of national RINs. Giant's one of them. YesNet, we are an international one as well. They're a little bit different. So a normal ISP, you've got a lot of small packets on big highways, right? So usually it's more like a bunch of smaller flows destined for Netflix or, you know, CDNs or things of that sort. YesNet's a little bit different. We are more of a purpose-built, big fat pipe, elephant flow network. So we kind of have different requirements from a lot of ISPs, even though we look like one. But we're here to talk about intent-based networking. So what is intent-based networking? Basically, our definition of this is that intent-based networking is a higher level way to define your network services. So instead of saying, you know, oh, I want a static route, you know, you're saying, I want to give a service to a customer. They use static routes to get, you know, traffic from us and to us. So we're describing what a service is, but not necessarily how to implement it, right? It's a really high level kind of design. It's the intention of what you're trying to offer. And the whole idea is that we're taking our service offerings that we give to customers, and we're just kind of removing that from how you actually do it, right? So a lot of benefits there around multi-vendor networks, so you're not tied to one vendor, and just not having individual engineers doing things their own way. You know, you're abstracting that whole service away from the actual implementation details. Orchestration. So orchestration, you know, at a really high level, is just coordinating things between computer systems, right? The way we do it, though, is we're taking that concept of coordinating these computer systems together, and we're basically translating that network intent, like, I want a VLAN in my data center. Things like that, and actually figuring out all the building blocks that need to go together to turn that into actual configuration, because that is what makes the spice flow, right? So we basically have a workflow-based method for provisioning these services, using a tool called the Surfan Orchestrator, which I'll get into a little bit. But really, one of the big benefits here is that we're trying to ensure consistency. Because I was talking last night around drinks, like, you know, maybe you have the one engineer who, whenever he goes and configure things, you know, he has his own way of doing it, and it's a little bit different. And when it breaks, you know, you got to call in Joe and figure out how Joe did it, and oh, it's a little bit different. Yeah, you know, we're trying to remove a lot of that human element of things because networking is hard. Like Joe's slide showed, like there is so much to a network today. So what is not orchestration? What is orchestration not? It's not going to replace network engineers. We actually have been increasing our engineering staff to support this stuff. It's not a way to have one engineer just do the job of a bunch of people. And for us, like it's not a single tool to run everything. Like we still have manual config. Like there's some stuff that is not worth automating because it takes a lot of time. We have like at least 12 people working full time on developing software to run our network. You know, and even then we don't have 100% config coverage. So the real benefits though are, again, consistency, right? Making sure that when I deploy a layer 2 VPN, it's done the same way for everyone. Layer 3 VPN, same way for everyone. Internet transit service, same way for everyone, right? And that doesn't mean we can't have differences in configuration. It just means that they are consistent within their product definitions. And ultimately, that reduces the chance for human error because you don't have Joe or John going out there and doing his thing. And it just makes the network more reliable. Because when you actually know exactly how it's configured and how it's working, you don't have to worry as much about the variability of things. And ultimately, what that allows our engineers to do, at least the idea, the hopefully virtuous cycle, is that the engineers can actually focus on designing networks. Because I think that's what we'd really like to do. Like nobody really likes doing the operational work of like actually going and figuring out, oh, okay, I gotta put an IP address on this side, oh, I gotta enable LVP, oh, I got RSVPT, I gotta turn that on too, I forgot to put a, CLNS address for ISIS to run, and all that stuff. Like, it's just busy work at the end of the day, right? The real engineering is coming up with service offerings to actually provide something to customers and make the internet work and make packets happen. So what's our actual stack look like? Well, there's a ton of stuff, but at the middle of it, we have the SurfNet Orchestrator, which is an open source product. It's not by us, it's developed by a peer network in the Netherlands. But yeah, it basically sits at the center of all these tools. So the really high level thing is we have network intent right up here, which is ESDB. That's an internal tool. It's really specific to us. Think of it kind of like Netbox, but we built it before Netbox, so we didn't use Netbox. And that stores the really high level intention around what services need to be offered. Layer 3 transit service to a customer, layer 2 VPNs, and even internal stuff like a backbone link between two routers. And when I get to the demo portion, I'll actually show you just basically the configuration process that happens for a real engineer deploying an internet BGP peering, right? So the orchestrator then is a workflow engine that's pulling network intent from ESDB, and it's talking to other systems like revision control with Git, or our IPAN, right, to actually reserve blocks of IP addresses and things like that. Talking to peering DB, RADB, IRR stuff, right, to actually get prefix lists so we can do BCP38 filtering and all that stuff, right? So it's basically talking to all these various systems that normally a human would be doing. It's pulling that all together, and then it sends it down to our mediation layer right there at the bottom. So you can use really any mediation layer you want. Joe mentioned Ansible. We're not using Ansible, but like if we wanted to configure hosts with our orchestration, right, Ansible would be a great fit. We're using Cisco's NSO, which it's not really like Ansible at all. It's more like Terraform, right? It's more like a model-driven way of doing things. But the whole idea there is that NSO has an abstract way of interacting with our network devices. Because as one of the questions was like, how do you deal with legacy devices? Well, yeah, that's the kind of dirty truth of networking, is dealing with network devices, it kind of sucks still. Like, even if you have netconf, or God forbid restconf, like, it's a pain. And like, most of your devices don't have that. And even if you do have it on all your devices, it's different on Juniper than it is for Cisco, than it is for Arista, than it is for so-and-so, right? So you can't just say, here's an RPC to define VLAN. We tried to do that with OpenConfig, didn't work because vendors want their special stuff, right? So because of that, we've created our own vendor abstract models for network config. So like a good example of this is something I'm working on currently, which is defining our routing policy in an abstract way, right? How do you do like a prefix list on Cisco? You have EQ, GE, LE, right? That's your way to define it. How do you do it on Nokia? Longer, through, prefix length range. You have all these options. Every vendor's a little bit different. So we define an abstract way of writing that, and then we implement that in the various vendor-specific ways. And that's what our mediation layer does. And that gives us atomic, basically, commits into the network. So you can commit to multiple devices at once. If it fails, rolls back the whole thing, doesn't actually give you a halfway baked change. The really nice thing, it's all model-oriented, so if you need to delete it, you don't have to actually write the steps to delete stuff like you do with Ansible. You just delete it and it's gone. NSO knows how to rip out all that config. All right, so what are our workflows? Really, basically, we have finite resources, right? Numbers, basically integers. All networking is like finite integers, right? IP addresses, VLANs, all ASNs, all that stuff, right? So those are all existing in other systems. Basically, we write workflows that are assembling all of those finite resources into an actual product, just like a Lego kit, right? So you can even do sub-steps, right? Just like writing software and you write a function that's reused by other functions. You're just writing small components that you can build to create a larger service offering. So our overall provisioning workflow, and I guess one thing I'll mention too is the other thing that workflow orchestration does for you, it doesn't just do a task runner. It's not just a list of steps. It also has a whole subscription model. So all those products that you've assembled together, it has relationships between them and dependencies. So I can't go and delete a low layer block if it has higher things depending on it. I got to tear down the higher layer things first, right, to prevent me from accidentally doing some stuff like that. Yeah, so here's like our, just general workflow. So very much like the circle that Joe pointed out, we have a network planner over here designing like an actual network thing, right? So they're kind of designing these services, working with our automation team and our orchestration team to turn that into an actual software offering. And then over here, you have a network engineer. They get assigned a task, and they're going to actually populate an instance of that service in our intent storage, our source of intended truth, ESB. So they populate that, and then they just go to the orchestrator, and they say, all right, make it so. John Picard raises his hand. That talks to NSO, talks to any other systems, updating artifacts like monitoring or IPAM or things like that. And then ultimately that goes to the network. All right, demo time. So this is a tool that a bunch of us built called Rover. It stands for Realistic Orchestration Validation Environment for Networks with a capital R. Like all good software, we start with an acronym, figure out what we do after the fact. So basically, this is where we do some of our testing stuff for software. So this is like a representative version of ESNet. Obviously, it's not that map from that first page, right? Because we have a lot of POPs around the globe. It's kind of hard to represent that into a virtual topology. So we have 5 routers, that's the circles in the middle. Those are running Nokia vSIM, which is a pretty awesome virtualization version of the Nokia operating system. It even requires you to configure power supplies or else it won't boot up the line card. So it's really awesome for actually testing this software. We have Juno's VQFX, which I will not talk about. And we have SR Linux running to kind of represent customer hosts. And so those are pre-configured with BGP like a customer would configure, right? Already set up the peering, it's ready to go, just wait on the ESNet side to configure. So this whole environment also has all of our service containers. So ESDB, Orchestrator, NSO, some of the ancillary systems that support that. So basically it's a little tool that we developed that lets you spin up a copy, a representation of ESNet within 3 or 4 minutes. All right, so we're gonna talk about BGP peering because we're all network engineers here. So first off, I'm gonna show you 4 services and how they line up together. So the first one is the physical connectivity service. That's very basic stuff. It's layer 1, layer 2, enable the port, no shut the port, turn on LLDP, that kind of stuff, right? Then we have the service edge workflow, which is actually the layer 3 addressing. So things like, put IP addresses on it, that kind of fun stuff. Then we have a prefix list service. So we do BCP38 filtering on every peer. So, if, we're peering with somebody, we have a service that goes and talks to IRR, talks to peering DB, talks to our internal registry of numbering that we have as well, and assembles prefix lists, push it out to the routers so that we have a list we can reference. And then ultimately we have this layer 3 IP transit service. This layer 3 service basically ties those existing Lego blocks that we've assembled in the demo together. All right, now for the fun part. Let me kind of show you the demo environment. So here is the workflow orchestrator. It's nothing fancy, it's just a little job runner, right? Here's the SDB. So again, this is an internal source of truth. It's really ESNet specific. I don't know, a lot of people ask hey, can I use that? You're probably better off looking at Netbox or something like that, or with custom plugins and whatnot, because we built this very specific to us with our own models. And so then I'm also going to have the actual network devices in our lab topology. So I'll get logged into real quick. So on the left is a core router. If I go back to that diagram here, that is basically location 1 CR6, and we're looking at customer 1 edge 1. So basically everything we're doing is on this link. We've got a packet capture as well running on this link, so you can actually see the packets flying by. Right now you can see the customer router pre-configured. It's trying to talk to the ESNet router. The ESNet router is not configured yet, so obviously nothing's happening. All right, so I'm a network engineer. I've been told, hey, we need to bring up, internet transit for this customer. Let's make it so. So I go into ESDB. Let's say we've already got the peer for the customer. So I go in here, I click on customer 1, and again, this is our source of intended truth. So this is kind of all the intent around this peer. So we have services, and it's a relational database, right? So everything's cross-linked to each other. So we have these services, which is where we store some custom IP addresses that the customer doesn't have an IR data that they need to advertise to us, things like that. And we have these BGP profiles, which allow us to actually configure some things do we want to accept their meds or not? Is that something we've agreed upon? Do we want to send them a default route? Things like that. And basically we have different profiles for different layer 3 VPNs that we have with the customer. And then we have the actual list of neighbors. So this customer has a bunch of neighbors, V4 and V6, and in the topology, they're actually the customer routers are linked together and running an IGP, just like a customer core. But the cool thing is, I said, all this is interlinked. So you can actually go and click here to the service edge, right, which has the layer 3 connectivity. And so I'm kind of working backwards from how we're going to orchestrate this. I've gone to the high level layer 3 service. Now I'm going into the actual interface that we're going to be configuring. So we can actually see the IP addresses we're going to configure on the SNet side. And again, relational database, so it still shows me all of the neighbors that live off this interface. You know, other applications can consume this and do cool things with it. But then, like if I actually click into this physical connection, this is our PCS, this is the first part I'm going to show off. So this actually shows you, which device, which interface, is it running VLAN tagging? Like, do we actually want to monitor this? What's the capacity of the port, that kind of stuff. But just to kind of show some of the power of ESDB, because I do have a little bit of time, we also have, the entire router equipment basically modeled as well. So, in here you can go to the equipment and you can see the entire list of interfaces, circuits that are tied to it, what state they're in, all that kind of stuff. So yeah, again, all this is in a demo environment, so I'm not going to actually take a customer down or update a real BGP peering, but it is happening on an environment that has packets flowing. So let's go to the orchestrator and do the PCS first. Again, this is the very base level unit that we're going to configure. It's just the basic LDB settings. So I've gone out and I've defined it. Again, really simple stuff. So I go to the orchestrator and I say, well, I want to deploy that physical connection now. Hit next, and the orchestrator has talked to ESDB and it's pulled in a list of all valid physical connections that we could deploy to the network right now. So let's choose the one we were looking at in ESDB, hit submit. So what it's doing right now is it's going and actually calculating what payloads to send to our network mediation layer, which again is NSO. And it's going to send that to NSO as a dry run. And basically NSO will return back, hey, this is actually valid from a configuration standpoint. And the engineer can then look at the workflow and decide, oh, is this doing what I want it to? So you can go in here and you can actually see like the actual steps involved, right? So there's a start step. Create a model. It uses Pydantic in the background to do that, and actually fetch information from our source of truth. Generate the description, which is basically just an F string, stuff like that. And then eventually, it actually sends it to NSO. And as a user, I go over here. I look at what's going to happen. Okay. On the actual device config, it's going to go to port 11C21. It's going to set the description, set it to access mode. That's not VLAN access. Don't get me started. Set it to .1Q tagging, unshut the port. Cool, looks good to me. Go ahead and confirm, hit submit. Now if I go over to the router, I should have done this before, but if I do show port, you can see, show port description, back at that. Over there on 11C21, we now see that description that we generated with our orchestrator. And this auto refresh isn't working for some reason. So now that's done, and that actually has a subscription ID. If I go to the physical connection in ESDB, refresh that page, the orchestrator is posted back to ESDB, the orchestrator ID, so that an engineer can actually look in the source of truth and cross-reference that back to the actual deployment engine. So now let's do the service edge. So again, this is a layer 3 interface. Since we're using a lot of Nokia here, they basically abstract all the layer 3 stuff from the physical ports. Unlike Juniper, you'd go into the interface and family iNet, that kind of thing. Basically, you create this whole SAP construct and then you tie it to a port. So our models kind of loosely follow that. So if I go over to the router and I do a show router interface, the only thing on here is the system, which is just a loopback. I'll log in here to the customer side. So yeah, we just have a loopback. We don't have any layer 3 interfaces towards the customer configured. If I go on the customer router, I do have a bunch of interfaces pre-configured and all that stuff, because again, this is for CI testing. So I can, set up a test to say, okay, run through these set of workflows, make sure that we're still receiving only the routes we're supposed to receive, right? Make sure our filters are still doing what they're supposed to do. And you can write, PyTest to do that. And then I'm going to start a ping to the SNet side. It's going to fail. You over here, you see the ping happening. Nothing's actually going. So let's go and actually deploy the service edge. So I select that product, Hit next. And it's just that first one there. Again, the orchestrator is going, pulling the list of validly configured intent sources in ESDB and saying, go for it. We can do some operational stuff, like if you want to admin up, admin down. We also have like this migration option that we're not going to really go into. But I hit submit, and again, the same process happens. So the orchestrator is going, we've defined this list of steps, it goes through, calculates all that stuff, figures out a payload, presents me with a dry run, I look at it, make sure it looks good. All right, yep, it's not deleting the entire config on the device. We'll hit confirm, hit submit, go back over here, and once that interface shows up, magic will start happening. Look at that, we got a ping. So, now we have basic layer 1, layer 2 connectivity, we have basic layer 3 connectivity. Next step is to actually get all the parts and pieces to run BGP. So stop that. Again, if I go to show router interface, there we go, it's actually being configured on the ESNet side. Everything's working. All right, so now I'm going to deploy a prefix list. So again, this is for BCP38 style filters, making sure that we're following manners, making sure that a customer can't advertise the entire DFZ to us when they have like one single /24, that kind of stuff. So I'm going to select that customer, and I'm going to choose the base routing table, because they have a couple different layer 3 VPNs with us. And I can actually select which routers that this customer has a presence on to deploy this to, or I can just let it go automatically and figure out where it needs to be deployed. So just go ahead and hit submit. And this one, it's pretty much a no-op, right? Because you're just configuring a peering policy. You're not actually attaching to anything. So we'll go, and we don't even need an engineer approval, right? We trust that the tool is doing what it needs to do, and an network engineer doesn't need to bother themselves looking at that. And so what's happening in the background here, which is kind of cool, is because prefix lists they can be pretty massive. Like we basically filter anybody who advertises less than 50,000 routes. So some of our prefix lists on peering fabrics and stuff with folks who have a lot of prefixes are, massive. So we've actually outsourced this to an external system that's running as a microservice called the Prefix Manager. And that runs, BGP Q3 and a bunch of internal logic to actually figure out which prefixes to accept and reject. So that's done. If I go to my cheat sheet here, you can see the actual prefix list on the box. Yeah, that's on the face. So there we go. We've got the V6 subnets that are going to be advertised to us. So now we get to tie it all together. And again, this is really where the power of orchestration happens, is because we have all these individual components. And I can actually show you, if we go to that earlier PCS, we actually go to the subscription. I could terminate this normally, but it's not going to let me do that because we've already built a layer 3 service on top of that with a basic IP interface, right? So we don't want to be able to tear this down and have NSO barf at the config all of a sudden because you've ripped out my layer 2, layer 1 interface out from underneath my layer 3 interface. So we model all of those dependencies in here. So now we're going to do that at the higher layer. So we're going to do the layer 3 service. So layer 3 service, we basically select the service edge that we've already deployed. Now, if you'll notice, this isn't that list that was really long from before because we've actually only deployed one. So the orchestrator only has a single subscription for one active one that's actually valid to tie to something else. Like you can't tie something that hasn't been actually built yet. Select that, and now we select the prefix list for that customer. And again, we can actually skip the dry run if we want. I got my cheat sheet here. Like if I do a show router BGP summary, we have basically our backbone peerings, like IBGP, that's it, right? We don't have any eBGP up and running yet. If I go over to the customer side with this really chatty SRLX command, we do have BGP configured, but it's in connect and active, right? So nothing's quite ready yet. And the reason these backbone peerings are in connect state as well, I just didn't configure it. So real quick, I'll just go ahead and skip the dry run approval because we trust the tool, hit submit. And while that's happening, we can go over to Wireshark and actually just filter on BGP. We see the customer trying to send an open, all right? It's like, hey, you guys ready to do BGP yet? You guys ready yet? And as soon as basically orchestration's done doing its thing, which is always going to take a little bit longer than I expect, and I have to keep rambling a little bit while I wait for it, we'll just see hellos start exchange, updates start flying, and actual routes going across the wire. There we go. So now if we go to the router, oops, we run that command. Look at that. We got 2 new peerings. over here. Look at that, we're established. And we're actually advertising 14 routes over V4. Yep, I'm getting 14. I'm only accepting 6, which is good. You know, then I can actually write tests around this to make sure that 14 and 6 is what's there, right? So the customer can't leak stuff to us. So that's the demo. That's a really high-level view of what we do. That's just one of the products that we have orchestrated in this manner. Other ones are backbone link between routers, because you know, when you have a national backbone, like it's all configured the same. Like, why are you going to type each one of those out by hand? Like, just as an anecdote, when I used to be in the engineering group, like I spun up a bunch of new ones on our European ring. And now, granted, I'm not a very good engineer. It took me like, you know, a couple days to like really get it all together and prepped and go to the IPAN and resolve all that stuff. Here, I just go, I click deploy, it takes a few minutes. So like there is a huge time savings to an engineer. And also, it's the boring work, right? It's done for me. I don't have to, I'm thinking about what kind of backbone links we need for capacity planning, not how exactly do I configure it. That's a real benefit to service orchestration. Hope this has been helpful. Open up for questions. I think we have 5 minutes.
Thanks, Chris. That was great, and thank you for using NSO. On your intent, because that seems to be the very important part, there were a lot of parameters. VLAN 2000 is an example, is managed, is not. How much of that is really required, and how much is like templatized or automatically fill in? Because I saw a lot of part where that designer might get it wrong or incomplete.
Yeah, it's a great question. So one of the hardest parts is actually defining your services in a templatized manner, and you're always going to want knobs. And so our goal is to reduce knobs as much as we can, but that's a constant battle between providing an actual configurable service to an end user versus just saying like, yeah, sorry, you can't do that with us. Or, oh, we don't do RIP. We only do BGP, right? So it's that kind of stuff. So we do have a lot of knobs still in our source of truth. We're moving away from that. One of our peers, Pure Networks Internet 2, last week I was at a conference with Carl Newell, who does a lot of their NSO design, and he put it really well, which was that compression ratio of config. So like, when you're doing a 10-base network, like what's your compression ratio of input to how much config is output? I haven't actually like crunched the numbers, but I think ours is probably like, you know, 10 to 1, right? Or 1 to 10, right? Like you put in one thing and you get 10 times the lines out. Especially when you look at the prefix list, it could be up to 100. So like there is still the compression ratio, but it's not it's not as good as it could be. And we're also working on that. But like the backbone link, for example, which I didn't give a demo of, that you go in, you create a circuit model, you tell it which endpoints, and you say make it backbone, that's it. Like you don't get to choose LVP, RSVP, SR, ISI, all that's just there. So like that's an input ratio of like 3 things to maybe like 300 lines. So 1 to 100.
Hi, I'm curious how you approach the problem of taking service definition and then automating the process to validate the operational state, especially when you're doing kind of distributed state across multiple types of devices.
Yeah, that's a great question. Right now, we do a lot of that by hand. We don't really have a pipeline that lets you test your specific network change before you roll it out. Part of that is because with a large network, like it's hard to actually model that. Like first off, the VMs that you can use to run that, Cisco's are okay, Nokia's are great, Junipers are lacking. Like you can't necessarily represent all your config in those virtual devices. So you need something like, you know, Batfish maybe, or Batfish. That's kind of it. So it's a hard one. We rely mostly on traditional monitoring. So like, you know, SNMP polling, streaming telemetry stuff for like actual flow data to see if things have gone wrong. What I would love to see eventually is in these workflows, after you've deployed the configuration, do what Joe was talking about, where you actually then check, can I do a ping between these 2 devices? And especially with running an MPLS backbone, you know, you can use OEM tools to do a lot of really cool stuff. Well, no further questions. I will unplug. Thank you everyone for your attention.